Welcome to Stevenage in the United Kingdom. This is the location where Airbus have been building spacecraft for over 50 years. Now they have another crucial project in their hands. The ExoMars rover, also called Rosalind Franklin, is getting its pieces together in a specially designed clean room. Let's have a look at what they are doing.
Hi,
Hello.
how are you doing?
Hello, Paul. Thanks for welcoming us.
That's all right. Welcome to our clean room. Do you want to come and see the flight rover? Come and see Rosalind?
Yeah, tell me a bit what are we going to see?
We're going to see the real flight rover today, which is in our biologically controlled clean room.
The real one.
The real
sure.
one, yes, the real one, the
Finally.
final one. Yes, so come on in. So this is the flight solar array. It's actually upside down at the moment because they're working on the underside of it. But that's one part of the rover that's being worked on currently. The other part is up the stairs. So come up on up and we'll have a look at the other half.
Here the rover is being fitted.
That's right. So the main thing they're actually working on at the moment is the locomotion system, which is being bolted onto the side of the rover, and then we'll test and we'll make sure that it all works correctly before we ship it off to environmental test. Probably the main thing that makes this particular integration unique is the planetary protection elements. So whilst we have tested different models of all the equipments talking to each other before, never have we had to do it with all the constraints of all the planetary protection and the cleanliness we need to ensure throughout the process. The goal of ExoMars is to find life on the surface, and more specifically under the surface of Mars. And that means that we absolutely cannot take anything organic with us. So that informs things like material choices. So the wheels on the rover, for example, are metallic rather than being made of rubber. But that also means that when people are working on it, they must not in any way organically contaminate the rover.
And I heard that humans are the main biohazard here.
Yeah, by far and away, yes. The dirtiest thing the rover will encounter throughout this process, unfortunately, are the humans working on it. So to be very, very careful in the way that they do work on it, the dress they have to the garments they have to wear, and how they actually go about working on the flight rover.
We shed like millions of particles or skin flakes every day in 24 hours. So now compare these millions every day to 9,800 spores that is the value of delivery after all the integration, after 1 year of integration and few months of testing. This gives you a little bit the level of challenge that we have. What is planetary protection? Why we are doing it? The objective of planetary protection is to avoid what we call forward contamination, which is basically contamination coming from Earth to another planet, in our case Mars. And this is mainly to avoid what we call false positive. A false positive is when our search for life instruments will detect life, but there is uncertainty if that type of life is indigenous in the planet or is coming from Earth because we contaminated the instrument. This is a changing room where we're going to get dressed to enter our bioclean facility.
ExoMars.
Well, the thing is we need to get dressed a little bit more careful. We need to wear sterile garments, and I'll show you in a minute how to do it. Okay, so the approach will be from the top to the bottom. So we will start putting our sterile gloves on because we have a sterile face mask. So to handle the mask, we need to put sterile gloves. So if you sneeze in the area, what you should do is leave the area, and then depending on the the amount of sneeze that you have, you can even be escorted out.
We have been told about all the challenges of keeping the rover clean to go to Mars, but what are the challenges of the environment over there once it lands?
One of the big things about Mars is that it's very, very cold there, but also that the temperature fluctuates quite dramatically day to night. So you've got to survive in this very cold environment. All of your batteries, all of your computers have to keep going even though the temperature is very low. I spent 5 years leading the design team for the structure of the rover, so including the bathtub. And the bathtub is really quite a bespoke and unusual piece of equipment. So it provides a lot of structural functions, but also things like thermal insulation. It's got to be biocontaining, so it's got to stop any contaminants inside the rover from getting to the outside and to the Martian environment. But also it's going to be one of the first carbon fibre structures on Mars.
What is this little thing here next to the drill?
So just on the side we have the Kloopy, which is the close-up imager, and that's one of the ways that we're going to look at the sample that we're bringing into the drill and detect whether there's anything interesting there, any microfossils or any interesting kind of chemical structures in our rock.
What is this? What is what you have here?
This is what we call the Mars yard.
The Mars yard?
The Mars yard. It is a simulation of the surface of Mars. We have a test rover, as you can see on the surface there, and we run it around on the surface, testing the different capability and the limitations of the rover we have.
Let's have a look.
Yes.
Wow.
So here we have it, yes.
Real Martian environment.
It is the simulation of what we expect to find on Mars with the sand and the rock, as well as dunes, as you can see in the background. The analytical drawer is the science package of the rover, which contains a number of instruments that are going and mechanisms that are going to process the sample and look for the carbon atom as a sign of extinct or extant life. It's very sterile because we want to find the life that's there and not what we've brought with it during the integration process here on Earth. I've been involved in Mars missions for quite a while, and it interests me, the specialist and the constraints of putting something on Mars and the ability to answer the question of whether there's life on another planet.
It's all getting integrated together, and you know that hardware that you once just dreamed of and was once just an idea in your head is now physically a reality, and it's actually going to another planet. I mean, that's pretty cool.
Be standing in front of the one that's actually really going to go. That's, for me, that's the reward of doing all of this. It's the end product, it's the end game now.